Hello.
Hello, everyone. Welcome to our live stream today on the MATLAB YouTube channel. I've got
Grace Woolson.
I'm Connell D'Souza, and we both work in education marketing within the MathWorks. So, Grace, what are we here to talk about today? I know there's a big slide on the screen that's telling us what we're here to talk about, but
Today, we're
let's give it a
talking
whirl.
about using MATLAB for hackathons and how to make cooler hacks in less time.
Yeah, should be fun. So we've got a little bit of an agenda today. We just wanted to sort of give you guys a high-level understanding of what we're going to talk about today. So Grace is going to talk about machine learning and deep learning. She's our resident machine learning and deep learning expert. And then we're also going to talk about how you can build apps. You know, we at the MathWorks, we love apps, and we use a lot of apps. We try to develop a lot of apps for our customers. But we're going to talk about how you can develop and package your own apps. And then we'll get into some Internet of Things using our Internet of Things platform called ThinkSpeak. And then we'll talk about using connecting your mobile device to MATLAB. So, you know, without wasting too much time, let's jump right in.
Yeah, so we'll go through all of these workflows today. But if you have any questions at any point, feel free to put them in the chat. We're monitoring it. We've got people monitoring it. We want to answer your questions. So we'll dive right into MATLAB. For those of you that haven't seen it before, this is what MATLAB looks like. You've got your standard command window. You can do your hello world if you're a programmer or if you just want to see something fun. On the left, you've got your workspace. This will show our variables. You've got all the files in your current folder. And then the tool strip up here has all the things that we'll be clicking on. So you'll see me use this a couple times throughout the presentation today. All right, so let's clear that. Now, I've got a handy-dandy script that I've got prepared for today that we'll go through. So let's start with machine learning. Let's say you're working on a hack and you want to use machine learning to predict something. For today's example, I have this carbig data set. So to run it, I'll just hit this run section button. And what this does, it loads in a data set. Carbig is in MATLAB, so you can run this on your own. And then it comes in as a bunch of different little variables, as you can see down here. So I just format it nicely into a table, because tables are always easier. And we can see we've got a bunch of information about cars. I've got acceleration, cylinders, a whole bunch of stuff, basically. So I want to create a machine learning model that can predict how many miles per gallon a car will get. You know, maybe someone wants to just predict this about cars. So first, with any machine learning problem, you'll want to do some pre-processing, but I'll let you do that on your own. I'm just going to split this up into training and testing data because we'll need one set of data that we'll use to actually train the model, and then we'll use another set to see how well it performs afterwards.
So I have a question. Is there like a good rule of thumb as to how big your training data set and your testing data set need to be? Or is that just kind of, you know, try and see what works best for you?
Yeah, no, that's awesome. So I have it started as 80% for training and 20% for testing. Sometimes it's 70-30,
Right.
Sometimes it's 90-10, but that's a pretty common division that you can play around with.
And the reason you want to do that is because you don't want you want to make sure that your network is being tested on data that it hasn't seen before, so it's not
Right.
overfitting to a particular data set. Right?
Absolutely.
Cool.
Yeah. So then I'll split this up into my training and testing data, and then we're going to open an app. The name of the game today is apps, and so we'll start with the regression learner app, since this is a regression problem, since miles per gallon is a non-discrete number. And we can do this either through the command line or through this fun apps tab. And you'll see I have it favorited right at the top, so I'll just click this to open it.
Before we get in, can we show everyone just all the apps that we have available? There's,
Absolutely.
As we said, you know, at the MathWorks, we love apps.
So-
as you can see, there's a whole bunch of apps for various application areas, including robotics, signal processing. We're going to focus on the deep learning and machine learning piece of it today, but there's definitely a lot for you to explore.
So many apps. Yeah. Cool. Yeah, and then you can also run that programmatically. You'll be greeted with this window. You'll need to start a new session from the workspace because that's where all of our data is. And that'll open this pop-up. We'll select training data, which we just created. And right now it auto-defaults to weight just because that's the last column in the table, but we'll set it to miles per gallon. We have a couple redundancies, like we have 2 things for cylinders, we have 2 things for origin, And it'll automatically select some validation data, which is just a little bit of your training data that's set aside to check in on performance while you're training, just to make sure things are going well. And we'll hit start session. And basically what this is going to do, it'll load your data into the app and get ready for you to start creating machine learning models without having to write any code. This response plot is the first thing that you'll see. What this does is show you the relationship between our miles per gallon, which is here on the left, and the various columns that we have. So record numbers, not super interesting, but we have weight, which, as you might expect, as weight goes up, miles per gallon goes down. So this gives you the opportunity to explore your data a little bit and the relationships between different variables. To train a model, you can set all these options, customize it as you want, but we're just going to go simple today. We're going to choose the model that we want to train. So I'll click this all quick to train, and I'll delete the tree because if it's not quick to train, we don't want it today.
So I'm guessing we're testing a number of models that we can, and MATLAB is going to do all that in the back, and then we can, so there's, again, the thing with hackathons is you don't really have a whole lot of time to try stuff, right? You've got a weekend maybe. So you want to focus on tools that kind of do a lot of things for you. So you can, because at the end of the day, your goal at a hackathon is not to build the best deep learning model. It's to build a hack, an application, right?
Prototype.
Right. And the model may be a small part of it. So we want to look at tools that can help us sort of do a lot of things for us. Exactly.
Yeah. So yeah, this will find a couple models that are pretty quick to train. I'm going to use Parallel because I have Parallel Computing Toolbox and I have a computer that supports it. And then I'll click Train All. And you'll see on this left tab here, there will be 4 different models that are this quick to train class. And the app's going to just train them all for us, find the best weights for our machine learning models, and it'll return this RMSE, or root mean square error, which error you want lower. So this top one has a lower error, so it's highlighted. It's saying, hey, out of all the models you've trained, this is the best one so far. And we have our response plot again, but now it's added the predicted outputs of our trained machine learning model. So the further away these yellow dots are from the blue dots, the higher error there is. So we see a lot of these dots with short red lines, a couple that could be better. But we've got a pretty solid starting point. And then we're going to bring in that testing data that we made earlier. And it'll automatically detect that we have the same columns. We'll import it. And then pay attention to this RMSE value as I click Test All, because it'll quickly run all the models with the new data. And we'll see that the performance of this top one got a little bit worse and the performance of the other ones got a little bit better, but overall this top one still performs the best on both the training data and the new unseen data. So this is the model that I'm going to want to use for my miles per gallon prediction. Now we can just export this model straight to the workspace, and you can change the name, but I think trained model is a pretty good name, and we'll hit OK. And as you can see, well, maybe not because we have a lot of variables, but we should have a trained model right in the workspace. And when you export it, it'll even tell you how you can make predictions on new data using this model. Okay, great. And if we go back, we'll also see this generate function, which I think is really cool. Yeah. What this does is basically generates the behind-the-scenes MATLAB code for you. Whether you want to make this reproducible, you want to make small tweaks, or you just want to learn more about the code that goes on behind the scenes of machine learning, you can have the app generate that code for you.
Yeah, and this is something that's valid for, I'm going to say, most apps, if not all apps. You can, whatever. I like to call it the pointy, clicky things that we do with the apps. MATLAB's making sure that the code is being sort of recorded in the back. So if you want to create a function, it's just a matter of exporting that function, which you can use in other places as well.
Yeah. And that's it. We're done. In a few minutes, we've made a complete machine learning model that you can use in your hacks or as your hacks. And we can do something similar with deep learning. Yeah.
So I think since we're skipping, we're switching topics.
Yeah.
I think now's a good time for some questions. Does
Absolutely.
anyone, if you have any questions in the chat, I know our our fabulous video team that's helping us with this live stream. They've actually just popped a poll into the chat. So if you're if you'd like to let us know what level of experience you have, maybe we can in real time try and modify our session content for you, which it's always fun. I like doing things in real time. But anyway, if you have any questions, please, now's a good time. We can take a couple minutes and try and answer some of them for you. Doesn't look like we're getting anything. Tough crowd, huh?
Tough crowd. I think that just means I'm doing well.
Exactly. Maybe we're just doing too well with the content. But anyway, Grace, if you want to move ahead to deep learning, let's go ahead and do that.
Yeah. So there are some problems where deep learning is just going to work better than machine learning, whether that's, it's too complex or maybe the data just works better. So for this example, we have a data set of images. And this is another set that's completely in the product. It's a food image data set. So I'm just going to run this section, and it's going to unzip the file, basically, that comes with MATLAB. And it'll return this file path so that we can look at it, except I'm going to run this in the command line to make it copy-pastable. So it returns the file path. So let's look at what the data looks like, because it helps to have a sense of what your data looks like. Awesome. So it looks like we have 9 folders of food data. So it's all pictures of images. So this top folder is all pictures of Caesar salad, pictures of caprese salad, French fries. You get the idea.
This live stream is too close to lunch.
I know, I'm gonna get hungry.
But all right, let's keep going so we can get lunch. I'm kidding.
All right. So let's say we want to train a network that can, if it sees an image, it'll tell you what kind of food is in that image. So first, I'm going to create an image data store. We have lots of resources on what these are and how to use them, but essentially it lets you import large amounts of data, especially images, and it works really well with deep learning. So
yeah, the image data store it's really cool because one of the problems that you run into pretty often with large data sets is you're running into out of memory issues. So I like to think of the image data store as like a pointer. It points to where your data is located, and it's only loading in what you need when a particular function is calling that data. So you're not running around with a whole lot of memory being sucked up by your data set. So.
Especially, I don't know about you, but when I was in college, my laptop did not have a lot of memory in it, and this would have been a lifesaver. So great. So we've got this pointer to our data. And we're going to open another app. We're going to open the Deep Network Designer, which I'll do from the command line this time. And deep learning can be kind of intimidating because there's a lot of different kinds of networks. But with the app, you don't necessarily have to know what kind of network you want to make. You can totally make one from scratch if you have an idea, or if you've imported one from somewhere else, you can import it from the workspace. But we're going to start with a pre-trained image network. There's a whole bunch of them here, but let's use GoogleNet. And what that's going to do is it'll open the network, display the architecture, and let you make your own modifications to the network. So it's going to, beautiful. So this is the whole architecture of it. It's a lot of information, but you don't need to know everything, especially when it comes to transfer learning. The most important thing is these last few layers. And when you zoom in, you can see that there's more information about the layers. So we have this fully connected layer, a softmax layer, and an output. And these three are essentially responsible for calculating the correct class. But right now, it's trained for 1,000 classes because that's how many GoogleNet was trained for.
Yeah.
So we're going to remove those. I can just click on it and hit backspace. And then we'll find new ones to retrain. So fully connected, you can just drag it. Love drag and drop. Again, not writing a single line of code. And then we'll go to our outputs.
Yeah, again, transfer learning is something that could really help you out at a hackathon because typically the one concern with deep learning is you need a lot of data, you need a lot of time to train your models. You also need a lot of computing power, and if you do not have either one of the three, maybe transfer learning is a good way for you to get that because you're essentially taking what a network already knows and sort of remapping those features that it knows to identify to some classes that that you're interested in, right? So again, if you're at a hackathon, you probably want to consider transfer learning because
Absolutely.
it'll help you get things done quicker.
A few tweaks and you're done.
Yeah.
We'll change the output size to 9 because we have 9 classes of food. And then your network's done. We got to bring in our data, so we'll go to the Data tab, import image classification data, and we'll just select the data stores that we created earlier. So our training, and we made a validation data set. Before it, in the machine learning one, it automatically took it from our training data, but this time I made a separate one just to show that you could do that.
Yeah.
Cool. And then we'll click import. And this will, again, connect the data to the app and give you a little preview of how many images you have, the distribution, do they look okay. Then we can go into training. You can customize how you want to train it using this training options. There's a whole bunch of them. Again, it's super interactive, but I'm just going to use the default here. And then you would click train. I'm not going to because, again, deep learning does take a little bit of time, and we're going through a lot today. But if you clicked train, you would see an output like this, where it shows you the progress. There we go. Shows you the progress of your accuracy and loss as training goes on. So ideally, accuracy increases, loss decreases. And then from there, there's this export button. And if you click on it, again, you have the option to export your network to MATLAB. You can generate code just like we did for machine learning, and a couple other options if you're really going crazy. But that's it. Again, in a matter of, 15, 20 minutes, we've made 2 AI networks, which could have taken a long time to do programmatically.
Yeah. And I mean, I'm not a programmer. I'm not a computer scientist. I am a mechanical engineer, right? I just happen to work for a software company. But I'm not interested in a tool that's going to make me have to write all the back-end stuff because it's not my cup of tea. I don't know how that works.
Sure.
So if I can do pointy clicky thingies and get and get code, that's perfect. So again, generate code. That's you can most of our apps are generating functions for you, so which you can use in other places as well. So yeah, good things for us to have on your app.
Absolutely. And even if you do know what you're doing, it just saves a lot of time.
Right. I mean, as again, I said, at a hackathon, your goal is not to build the best network, or it's to build a hack or an application, right? This is a part of it. So, yeah, anything that can help save me time is good for me.
Okay. We got any questions?
I don't know. I think we're doing a real good job because no one's asking us any questions. But hey, if y'all have any questions,
Put 'em in.
Put them in. The other thing that y'all could also do while you're hanging out with us is, if you like the content we're presenting, I know we try and do these live streams pretty periodically. So if you want to learn more about some of the tools that we've got, and I know our video team's gonna love me when I say this, but please smash that bell button on the YouTube channel so you can subscribe and get notified when we're doing more events like this. But yeah. I don't see any questions coming in the chat, so I think we can move forward with whatever we've got next to talk about.
Amazing. Next is my personal favorite kind of hackathon project is the apps.
Okay.
And once again, we're going to use an app to build our apps. So MATLAB has an app designer.
App inception.
I know, right? Let's just start with something simple. I'm going to start with this blank app over here. And it's going to load a UI that actually looks pretty similar to some of the other apps you've seen. We've got our interactive buttons over here, properties on the right, and this in the center, this gray box, is what your app will look like. So let's say we want an app that's going to display something. We can grab this axis over here and just drag it into the middle. I don't need this much space for a starter app, so great. Now we have a fun axis. And let's grab a slider. Let's say we want to just make a simple demonstration of what amplitude is, a little educational tool. So I will call this amplitude and hit run. And it'll prompt you to save it, so I'll just save it. And it'll open this app in a new window. And it's totally interactive. Great, the UI's done. But it doesn't do anything yet.
Yeah.
So let's close it. What I want to do is, let's say when we move the slider, have the amplitude or some display of amplitude show up on this axis. So that's going to be a callback. If you want, when you change something or when you interact with something, call some code. So I'm going to click on our slider, click on callback, and then you'll see value change function. So when we change the value, we're going to write a function. And it'll bring you to code view. And here you can see that all the skeleton code of our app has been written for us. Even like the things that we drag and drop, our axes, our amplitude slider, it's all here. It's named for us. A lot of the heavy lifting is done.
Again, less code for you to write.
Yes. But we do have to write the actual callbacks and what we want our code to do, the very custom parts of it. So I want to plot. Plot does not have a capital. And then I want to plot on the axes, which we can see is called app.ui axes. And we'll plot the value of that amplitude slider times the peaks function, which just provides a fun visualization of what that looks like.
Yeah, one thing to note is App Designer works on object-oriented programming, so you have to essentially establish some kind of inheritance. Again, a lot of it is already done for you in the backs, but for example, if you want to reference specific things, you always got to do the app dot whatever.
And all the names are over here.
Right.
Cool. We'll go back to design view. We don't have to. I just like the design view. We'll click run. And again, ready? Moment of truth. Woo!
Oh, fancy.
But the axes on the left keep resizing, so we're not really getting a cool idea of what amplitude is like.
Right.
So let's close that. Now we'll click on the axes, and we'll go back to this part, which shows all the properties.
There we go.
And I'm almost certain that, there we go, rulers. All right, y-lim. We want to change the limits of the y-axis to be negative 1,000 to 1,000. And you'll see that it automatically turns off the auto resize, so it'll stay to the shape that we set it to. And now if we hit run, it'll open again. And there we go. We've got a fun educational tool on what amplitude can do.
Yeah, it's pretty cool.
Now, this is a pretty simple app. I'm going to open a more fun app just to give you an idea of the kinds of things that you can do in App Designer. Maybe it'll give you an idea for your next hack. So we have a whole bunch of examples kind of just built into App Designer. So I'll click this one. It might take a second to upload, but we'll see that it has the axes, it's got radio buttons, it's got a drop down. I'll run it so that we can play with it for a second. So yeah, we've got a drop down, we can check boxes, we've got these little panels, all kinds of fun stuff. So your apps can get pretty complicated. Even this is on the simpler side of some of the apps I've seen.
Yeah, and I think something that we're not talking about is because it's just MATLAB. I mean, we've got a whole avenue of Simulink that we're really not. We're not talking about Simulink a whole lot in this particular live stream, but you can use apps as your front end to control Simulink models in the back. So if you parameterize a Simulink model, for example, or you want to, I don't know, you're flying an airplane, we've got some pretty cool visualization tools that you can put into an app and even pass data between the Simulink model and back. And so yeah, it's there's a lot of it. This opens up your opens up a whole lot of opportunity for you. We used to, a few years ago, we had this tool called Guide, which was the old version of App Designer. But App Designer is the way to go. It helps you, especially dealing with the sort of skeleton code, right? Because I mean, like we can go into the code view for this app, and really, it's if you look at I'm not sure if y'all can see it, but all the gray shaded areas, all stuff that the app just puts in for you, and that can be pretty helpful in terms of, otherwise, you're trying to go and identify, I need to move this particular component 5 pixels, and that can take a long time, especially if you're trying to do something in a weekend. So yes, App Designer is the way to go. Another thing that I'm sure Grace will talk about is you can run these apps independent of MATLAB. Like, you obviously need MATLAB to build the app, but once you've built it and you want to deploy it places, you can, we can talk about how we can develop standalone desktop apps.
Absolutely. So you can share these apps with others. There's a couple different ways to do it. MATLAB app, just share it with other MATLAB users. They can install it and use it like we've been using these apps. Standalone desktop app is probably the most popular for hackathons. It's just ensures that everyone can use it. But you just click package, and people will get something called MATLAB Runtime, which lets them use the app. And then you just set your metadata, so you'll call it what you want. You can set your custom picture. You put any file dependencies in there. So like if you were using a machine learning model, for example, you could save it in a mat file and then load it into your app. And then you could use your machine learning model in your app.
Right.
And then you hit package, and it'll just create an installer for you that you can email to someone else, and they can install this on their computer, whether or not they have MATLAB.
Yeah. And so the reason they're able to do that is because of this thing called MATLAB Runtime and MATLAB Compiler. What that does is it allows you to run these apps independent of MATLAB. So you don't need to have a MATLAB license to run the app. They can't. The person you're giving it to obviously cannot edit the app because you need MATLAB for that. But they can at least use whatever functionality you've built. So, yeah.
Yeah. And I will say also, I love App Designer because I have a computer science background. I like the coding part of MATLAB, but the visual stuff I just don't get. And it just streamlines it all. So, huge fan.
And that's clicky for the win.
Yes. And we're done with apps. We've got our apps. We've got some machine learning models. Do we have any questions?
So Pragati is asking us, can you please help me with coding for the similarity between a fingerprint and a footprint? Ooh, that's a very specific question. I don't know if I'm the right person to answer that.
We have some community forums that might be able to help a little bit more with starting points.
Yeah, but I mean, I'd say that could be a good application for deep learning, maybe, or machine learning, if you have enough data on fingerprints and footprints. But no, I don't have a more specific answer for you, unfortunately. Yeah, just because I couldn't answer one, please don't hesitate to ask us more questions. We're gonna hang around here for a little bit more. So we're at about 11:30 right now, Eastern Standard Time, here in Natick, Massachusetts, where the MathWorks is. I think we're at the point where we sort of move to a little, we start talking about hardware, and I'm going to have our fabulous video team help us with some setup stuff in the back, so they can switch over to my screen, so I can show you a little bit more about hardware and things like that. But if you've got any questions while we're getting set up in the back, please point that in, pop that into the chat. We're happy to answer as many as we can.
Just gonna give it a minute.
Yeah. I'll try and see if there are any more questions in the chat. Ooh, we've got. We've got answers on the poll, and so it looks like most of the people on this stream are beginner users of MATLAB. I think something that we can do is we try and put a lot of resources for people to learn. So we've got a Learn with MATLAB page, and we've got a number of what we like to call on-ramps. I'll show all the page a little later once we get my screen up. But there are a number of what we call on-ramps. So we've got on-ramps for a number of products like MATLAB, Simulink, Simscape, Stateflow now, I believe. Also with machine learning and deep learning. So, and the good thing about these on-ramps is that they assume you are absolute novice users of MATLAB. So you come in with, they assume that you know nothing, and then they sort of try and build up your skills from there. Oop, and I think my screen just flashed for a second, but then it went back off again. But anyway, for all our beginner users on this stream, we'll pop in a link to the to our learning resources where you can get started with MATLAB and learn about all the different products that we have got.
Cool.
Okay, I think we've got some more questions. How could we use MATLAB App Designer to create real-time hardware in the loop app? Okay, this one's one of those things where you'd have to connect it to Simulink. So Simulink is where you've got access to real-time hardware. I think we can once we're done with this, I'm going to look up a link that I can send you for that. But there are definitely ways in which we've definitely seen a lot of customers use App Designer as a way to build kind of like a virtual user interface where they can essentially tweak a bunch of knobs to send new information to Simulink and update parameters. But we can definitely pop a link to that into the chat. I'm sure there's a bunch of resources on that. Alrighty, so I think we've dealt with our technical difficulties with getting my screen up. But so what speaking of hardware, I think the first thing that I want to show y'all is MATLAB and Simulink both can talk to hardware in a variety of ways, right? Simulink is really the tool for hardware because you can essentially build up Simulink models and then deploy them to a variety of hardware boards. So I'm going to show you a list of all the vendors that we support. And by support, I mean we have these things called support packages, which are typically free if you have a MATLAB and Simulink license, along with some of our Coder products. But the support packages themselves are free. But as you can see, we support a number of hardware vendors, including things like 3D robotics, AdLink, analog devices. We also support deploying code to Android and Apple devices. So if you want to build a mobile phone app, that's possible as well. You can write some code, and I'll show you some of it in a little bit. But you can access the sensors on your phone and essentially use that to do any kind of activities that you'd like to for your hackathon. But then we also support the Arduino and the ARM boards and a whole we're only at F and G now. There's a whole list of hardware that we support. But essentially there are three levels of hardware support. You've got live data streaming. So say you've got sensors connected to an Arduino, for example. There could be things like proximity sensors, sonar sensors, you name them. You can read that data into MATLAB through an Arduino, and essentially once you pull that data into MATLAB, you've got the power of MATLAB at your hands, right? The sort of second level is generating code and targeting. So what we mean by generating code is where it's different from the apps generating code that we spoke about. The apps generate MATLAB code.
Right.
When we talk about generating code and targeting, we're talking about native code to the processor, right? So if it's an Arduino, it's C or C++. If it's a Raspberry Pi, it could be C or C++ again. What code generation does is code generation essentially takes your MATLAB or Simulink code, converts it into low-level C++, and then deploys it onto the hardware, and then it's running independent of MATLAB, right? But we also support things like the Jetson boards, which are GPUs, so they need CUDA, or HDL boards, boards that use HDL as a native language. So we have a variety of hardware that we support. And then the last one is project-based learning. We work with a lot of educational kits, if you will. So we've got the Arduino engineering kit. We've got the Parrot mini drones that we support. So you can, if you want to try programming a drone, you should take a look at the Parrot mini drone, or even maybe participate in the MathWorks mini drone competition, which is if you look that up on Google, you should be able to find resources for that. But yeah, so there's a lot of hardware that we support. We're not going to go into specific hardware today because we've done a number of live streams on that in the past, and we'll have our friends in the video team send that over to you in the chat. But yeah, please check those out. There are a bunch of resources available. The first thing that I'm going to do now is talk about our Internet of Things platform, right? So Internet of Things, it's something that's taking over the world now. Everyone's got IoT devices, whether you've got things like smart speakers, smart lights, smart doorbells. I don't know. There's so much of it everywhere, but
Everything's connected.
everything's connected essentially. Yeah. We at the MathWorks, we have our own IoT platform called ThinkSpeak, and ThinkSpeak essentially unites the power of having connected devices, but being able to use the power of MATLAB's visualizations and algorithms for a whole number of things, right? So at a high level, ThinkSpeak is essentially it's an IoT platform. We've seen a lot of people use things like ThinkSpeak for environmental modeling, smart farming. That's a real big application. Everyone's trying to be a lot more climate conscious now, and essentially over irrigation, is a big problem. You're wasting a lot of water. Right. Plants don't really need it. It's just water that's literally down the field or down the drain. But we've seen people using connected devices to monitor smart farming, and you can take a look at these projects on our on the ThinkSpeak website. But essentially, at a high level, what is ThinkSpeak doing? ThinkSpeak is allowing you to collect data, right? So you can either send sensor data privately to the cloud or send them as public channels. We've got a lot of so channels are essentially the medium through which data is being transferred over ThinkSpeak, right? But we have a number of public channels that a lot of our users put out, but you can also use ThinkSpeak in a private way, say in your home, where the whole world doesn't have access to the data that's coming out from your devices. But then because you're able to publish this data, you're also able to analyze it in MATLAB, and I'll show you how we can do that. And then lastly, app. You want to trigger something. You want to, I don't know, if it's too hot outside, send a tweet or send an email to yourself to wear a jacket. I don't know.
Drink water.
Right, exactly. So that's at a high level what ThinkSpeak can do. So I'm going to do a quick demo on ThinkSpeak to show you what it is. But essentially, what you see up top is you've got channels, apps, and devices. Channels are all the different data sources, if you will, all the different sort of data points that are beaming out data at different sample rates. So we can take a look at some of the public channels that are available. I'm going to try and look through and see. So, for example, this is this channel, the weather station. This is the MathWorks weather station. We've got a weather station in our office in Natick, and if we click on this, we can see where the location is, what the wind direction is, wind speeds, humidity.
It's going down.
Yes, it's been kind of nasty. It's been kind of nasty out here for the last few weeks. But temperatures they've kind of been in the 60s Fahrenheit for all our friends that do not follow the American system. But yeah, so essentially this is data that's being beamed out. We have a little weather station set up in one of our garages at the office that's able to. It's got like humidity sensors and temperature sensors and a wind speed monitor and all that kind of stuff, and we're just beaming that data out. So now, what you can do is if you're interested in what the weather's like in Natick, you can just go to this channel and essentially subscribe to this, and you will get a real time or whatever updates at whatever sample time the channel is publishing data at, right? So this is an example of a channel, and its access is public, and you can also export this data, as JSON, XML, CSV, what have you. If we take a look at so this is kind of what that weather station looks like. It's in one of our garages. But anyway, so that's the channels piece of it. We've also got apps. So apps are essentially things that you'd use to analyze or manipulate that data in some ways, right? So let's take a look at some of the MATLAB analysis kind of apps, right? So the workflow for creating a new app is essentially you click new, and we've got some templates. So you can either have something which is no starter code or get data from a private channel. But I'm just going to show an example just for fun, right? So what I'm going to do is I'm going to scrape some temperature data. Yeah. Because you're not just able to grab data from channels, you're also able to grab data from websites, right? So what we're going to do is we're going to use a weather service. So forecast.weather.gov, which is a publicly available service that's telling us what the weather is, and essentially grab that data in and then write the output to some channel, right? So I'm going to go ahead and create a new channel, which is this is a public channel that I'm creating weather for the live stream. I think that's a very unique name.
You might be able to find it after this.
Yeah, actually, I should make it. I should make it public.
Yeah.
But what I'm going to say is, so you can enable a number of fields. So I'm going to enable the temperature field, and essentially you can turn this on, right? So if you turn it on, it'll open up a new field. I'm only really interested in the temperature for now because it's just an example. But you can also go in and add metadata. So in any information that you'd want someone that's using this channel to know, you can group fields by tags. So you can say, okay, like if you have wind pressure, wind speed, etc., you can tag all of them as a wind tag. Also, link to external site. If you have a GitHub repo that's got the code, you can use that as well. You can also give it location details, right? So obviously, like for example, we saw the weather station. That weather station is specific to Natick, so
right.
we can put in latitude and longitudinal data. So whoever wants to use that channel is good to go, right? So okay, so I'm going to go ahead and hit save channel. And now you can see I've got it's one of my most recent channels that was created here. The thing that's important in the channel is the channel ID. So I'm going to go ahead and copy that. And I'm going to put that in here because, I messed up.
I don't know why I took the equal sign, but.
Yeah. But essentially this is what I'm doing is I'm going to grab the data from the website and then publish it to this particular channel, right? The other thing that I want is the right API key. So this is again this is what you're going to use to write data to that channel, right? Now, what I'm doing here is I'm essentially grabbing that URL, doing a web read. So web read is a MATLAB function that essentially reads everything on the website in I believe HTML form. And then URL filter is, I believe this is actually a file exchange entry that essentially filters stuff out of so it's good for collecting numbers off of websites, right? So if you've got a website that says, oh, temperature is so much, you can filter that out, right? So I'm essentially saying, use this tag to grab the temperature from that URL filter or from that website that I've just read, and then we're going to display it. We can essentially, so this is the code. Let's go ahead and save and run for now. And in the output, you'll see that, okay, it's grabbing the temperature in Natick, and it's telling me that's 65 degrees Fahrenheit. I should have bought a jacket today, but
It's 65 today?
yeah, it's kind of
Oh, no.
it's kind of crisp outside. So what we've done so far is we've just pulled the data from the website. We haven't really published it to the channel, right? To do that, we use something called the think speak write command, which is essentially we're going to give it the channel ID that we want to write to, what number we want to, or what data we want to print to that, and then the write key, which is what we grab from the channel. So if I go ahead and hit save and run again, it should publish to my channel. Now I'm going to go to my channel real quick, and you see that we've got that little data point that says it's 65 degrees at 11:45 a.m. EST, right? Now I've not set that channel to auto report, if you will, but I can go ahead and run it in a couple minutes, and you'll see I'll have a second data point. So if I go and run it again, it should give me a second data point. There we go. So we've got two data points. Now within the channel, I can add visualizations. So either plots and so on and so forth, or I can add more widgets. So things like gauges, numeric displays, image displays. You can also send images over this. So if you've got a cool project that we have on ThinkSpeak is one of our engineers, the MathWorks. What one of our engineers, the MathWorks, did was they installed a a camera on looking at the highway that goes in front of the office, and it counts the number of cars that are going by every day. So
Really?
it tells you if there's traffic or not, and what time you should leave work.
That's helpful.
Yeah, so there's a lot of cool stuff that you can do with ThinkSpeak. It's connected devices. We can pop a link into the chat to the ThinkSpeak website that you can go and check out some of our examples, as well as some of the wonderful projects that some of our users have created. But yeah, the last thing that I want to do before we sort of call it a day is I want to show you MATLAB Mobile, because I think MATLAB Mobile is really cool. So essentially, what MATLAB Mobile is it's a way for you to run and edit to some extent MATLAB code on your mobile phone. So what I have here next to me is my mobile phone that's got MATLAB Mobile running. I'm going to go back to the command line. So if you look at it, it kind of looks like it's connecting to the MathWorks cloud real quick.
There you go.
But essentially what I have here, it looks like the MATLAB command window. So you can go ahead and essentially say, I don't know, we can do what is it? Who? No, what? Is that a good command?
I can't remember. Is it what? Yeah.
Yeah. So like I don't know, you can go ahead and type various MATLAB commands into the command window. So if you don't need to use your calculator anymore. You can do all your fancy calculations on MATLAB Mobile. But anyway, so this is one piece of it. But the thing that I really like about MATLAB Mobile is that I'm able to essentially access all the sensors on my phone. I've seen this a lot. So we work with a lot of students that build robots. I've seen students stick mobile phones into their robots and just use the accelerometer, the gyro, all the various sensors, rather than
The sensors are helpful.
rather than going and trying to buy a whole bunch of sensors and set them up and deal with the noise. They're like, you know what? The phones have figured this out, decades ago. Let's just use them, right? So, so essentially, we can go into the sensors area of the app. Now, what you're able to do is you're able to stream data to MATLAB from MATLAB Mobile, right? So you can either stream it to MATLAB or you can stream it to a log where you're essentially just collecting a mat file of a bunch of data. I'm gonna stream this data to MATLAB in real time. Okay, so I've chosen the stream data to MATLAB. It's telling me that because I'm on I'm using an iPhone here. Because I'm using an iPhone, I have to give permission to MATLAB to read the data. So I'm going to go to the More tab down here, and then says give MATLAB remote access to my sensors. So I'm going to hit OK, and as you can see, it's got access to my sensors, it's got access to my camera and the microphone. And something I realized yesterday was that an iPhone has 3 microphones. I didn't know that until yesterday.
The more you know.
The more you know. But anyway, so now that I've given it access, I'm going to go back to my sensors page, and then pick a bunch of sensors to stream. So I'm going to stream my accelerometer, the gyro, and maybe angular velocity, right? And so now that I've set up my cell phone, I'm going to go into MATLAB and essentially create a connection to my cell phone. So the way I do that is I write in a little bit of code. So it's m equals mobile device or mobile dev, and once I hit enter, it'll take a second. But you can see it's got a connection to my iPhone, available cameras, again the 3 microphones that I was talking about, and it's telling me that I've enabled the acceleration sensor, the orientation sensor, and the angular velocity sensor. This is something that I just did on my phone. So now what I'm going to do is I'm going to go back to my cell phone real quick and then click on start, right? So now what's going to happen is you can see it started streaming data to MATLAB Mobile or to MATLAB. And I'm going to move my phone real quick so I can just create some fun data for y'all. But if you can see me doing weird stuff, just trying to get this right in. Okay, so I've stopped streaming data. Now, what I can do now is I can go into, so let's call it ACC equals, and I have a function that'll essentially pull all that data that I just streamed to MATLAB. So Excel log and then M, which is the mobile device that I have. So what you see is this is all the fun data. It really makes no sense, but we can plot it and see what it looks like. So let's do plot and ACC. And what you should now see is, as we saw, my phone was on the table for a while, and then we kind of moved it around, so you can see how the data is generated. Now, this is just a way for you to access this data. You can create a lot of cool stuff with this, right? You can stick this into a robot, and you've essentially got GPS position, acceleration, and all that kind of fun stuff that you can use. So you don't have to go and break the bank and try to buy a very accurate GPS sensor. You've got your phone that can do that.
Right.
Pretty easily.
And this is a great way to make data sets if you want to work on machine learning problems.
There you
So,
go. Yeah.
we've just created a cyclical live stream there.
Actually, hold on. We should do something cool and maybe post this on Instagram.
Because,
let's do this real quick. Okay, so cam equals camera of M.
And taking a selfie.
I think that's what we're doing.
All right.
Yeah, camera. Let's get the front camera.
All right.
And then we do. Let me just make this bigger real quick. I equals snapshot of cam, and then we want this in manual mode so we can actually click it, and it's not like But if you can see now, it's access my camera, and you can see the top of our video studio here. But if I go in and I got an image here. So let's do I am show of I.
Aw.
And we got a little selfie of us in our studio. So yeah,
That's
this is
awesome.
this opens up a lot of avenues for you in terms of what you can do with MATLAB. Yeah, so this was a quick overview of what MATLAB Mobile can do to you, can do for you, not to you.
Threatening.
I misspoke. But yeah, so this is all the sort of tech stuff that we wanted to show you today. I hope we've given you some ideas on what you can do for hackathons. We've got some resources for you to get started. So I think the best resource for hackathons is we're on GitHub. We've created an awesome MATLAB hackathons repo. So if you go through this, is essentially it talks about our partnership with MLH. So if you're participating in a major league hackathon, it's quite possible that you'd be at a hackathon that has a best use of MATLAB prize. So we're really excited to see what you use MATLAB for, and you could win some cool prizes from us in there. But if you're participating in an MLH or a major league hackathon, you have access to MATLAB. We've set up a complimentary license for you, which you can grab from this GitHub page. We've also got this little live stream that we just did. So we've posted a link to that.
You can rewatch it.
You can rewatch it. But these are some of the hackathons that we'll be featured at in the next few weeks to months, as well as we have a whole lot of like getting started resources. So these were some of the complimentary 2-hour on ramps that we were talking about. As you can see, we've got it for a number of topics, not just for MATLAB but for Simulink as well. And then some videos that we've made over the course of time. We've also got access to File Exchange. File Exchange is a real cool place to get started if you want to find code. I mean, you can find code on GitHub, but a lot of users have shared MATLAB code on File Exchange, and it's all open source. So as long as you have a MATLAB license, you can use this. But we've got so many MATLAB users that everything you've done has been done before. So it's a good starting point for you. And then we've also broken down some resources by application area. So things for data analysis, AI, app building, MATLAB with Python. You can call MATLAB from Python and call Python from MATLAB both ways. And we've done a number of live streams on that as well, so y'all can watch that. We've got some resources on working with hardware, finance. I know fintech is a big hackathon area. Climate change as well, IoT, the things speak that we just spoke about. So yeah, we've got a whole bunch of resources for you.
And something that you showed but didn't call out is MATLAB is also on the web. So I was using MATLAB on the desktop.
Yes.
But we also have MATLAB online. Doesn't require any install. That's what Connell was using. Connects right up to the Matlab Mobile.
And it's also got like dark mode, so that's kind of cool.
That's true.
But yeah, MATLAB's online. You know, you don't need to download the whole product. I think there is the functionality is not the same as the desktop. Like if you want to use hardware, you're probably better off using MATLAB desktop. But I mean, the MATLAB online works very well. It's just we can't talk to hardware quite yet on it, but hopefully soon. But yeah, so this is it. I think let's hang it on for a few more minutes and see if we have any more questions. But yeah, it was great hanging out with y'all. Hopefully we've given you all some ideas for your next hack, and
I look forward to seeing what you guys create.
Yeah,
when you get those submissions.
So I think what we're gonna do is we're gonna hang on for maybe another 5 minutes and see if anyone has any questions. But if not, we can call it a day.
We had a couple questions that were answered by our lovely moderators.
Oh, there's a question about image processing for multiple object detection.
We sent a link for that one.
Oh, we already got a link for that. Okay, that's cool.
But yes, we've got documentation pages too.
Yeah.
Super doable. We've got apps for that too. We've got apps for everything.
We call ourselves the app dealers now. All right, so it doesn't look like we're getting any questions. So either we answered all your questions already, or we're really good presenters.
All of the data and workflows that we showed today are available in MATLAB, so you can work with it. Our documentation.
We'll also pop in a link to that awesome hackathons repository in the chat. But if you, I think the best thing that you could do is go ahead and either star this repository or fork it, because then every time we make an update, you'll get the latest news. We try and meet our users where they are. So we know a lot of hackathon people that are interested in hackathons are on GitHub. So we've put some resources up here for you. Alrighty. So if it doesn't look like we're getting any more questions, so I think we can call it. It was lovely hanging out with all of y'all, and we hope that you'll join us again for another live stream at some point.
We're here every once in a while.
Yeah. Before y'all do anything else, please smash that subscribe button so y'all know when we're doing something else, and y'all can come and hang out with us again.
It'll be fun.
Thank you so much.
Thank you.
Whoop whoop.